Hello everyone, in the previous video, I already explained you a general explanation about global warming. Today, it's still about global warming, but global warming that relate to several topics, such as science, mathematics, technology, and engineering. For those who haven't watched the video before, the video link can be seen in the description box. As you can see, there are a lot of links between global warming and science, technology, engineering, and mathematics. But this time, we will only discuss a few points. Let's get started. Why does Earth have just the right temperature for life, neither too hot nor too cold? Two major factors work together to determine average global temperature. The first one is the solar radiation that Earth absorbs, and the second one is the concentration of greenhouse gases in its atmosphere. The Sun emits solar radiation, which is energy in the form of electromagnetic waves. It moves outward from the Sun in all directions, like a light bulb. Earth intercepts a tiny part of it. We receive only about 2 billions of the total energy released by the Sun. This tiny fraction is the ultimate source of almost of the energy used by everything on Earth. And it is also just the right amount of solar radiation required for sustaining temperatures suitable for life. A bit less than half of the radiant energy from the Sun is in the form of visible light. Electromagnetic waves have a wavelength ranging from 1,000 of kilometers to fractions of an atom. The longest waves are radio waves, then microwaves, infrared radiation, visible light, ultraviolet light, X-rays, and gamma rays. Energy and wavelengths are related inversely. The longer the wavelengths of the waves, the less energy it carries. Visible light has a higher energy and shorter wavelengths compared to infrared radiation. Atmosphere is transparent to visible light. Most of the light transmitted through the atmosphere is absorbed by the ground, although some of it is reflected back to space before it ever reaches Earth's surface. When the light energy that reaches this ground is absorbed, the ground in turn warms up and emits energy. But the energy that Earth's surface emits, which is called terrestrial radiation, has less energy and longer wavelengths than the incoming energy. Instead of being in the visible part of the spectrum, terrestrial radiation is infrared. Although the atmosphere is transparent to short-wave visible light, it doesn't allow the infrared waves to freely pass through. Carbon dioxide, water vapor, methane, and other greenhouse gases in the atmosphere absorb the warming terrestrial radiation. We emit it and we absorb it many times before it can escape into space. Thus, energy becomes trapped in the atmosphere by greenhouse gases, and this causes the temperature to rise. The process of trapping terrestrial radiation leading to increased atmospheric temperature is called the greenhouse effect. Now you can see how to calculate the total energy from the wavelength using this formula, the length times the frequency. Okay, next. Okay, now we are continuing to the technology one. The first one is X-ray. These short waves have enough energy to pass through soft body tissues or skin and muscle, but not bone. That's why an X-ray photo shows bones as shadows. High doses of X-rays can be very harmful. The next one is infrared thermometer. Infrared light works like visible light. It can be focused, reflected, or absorbed. Handheld infrared thermometer typically use a lens to focus light from one object into a detector, called a thermophile. The thermophile absorbs the infrared radiation and turns it into heat. The more infrared energy, the hotter the thermophile gets. This heat is turned into electricity. The electricity is sent to a detector, which uses it to determine the temperature of whatever the thermometer is pointed at. The more electricity, the hotter the object. The higher the temperature, the more electricity sent to the detector. the higher the reading. Okay, the third one is thermographic cameras. Thermographic cameras can take a picture of infrared radiation emitted by the subject based on its thermal condition, invisible to the naked eye. Most thermograms that you'll see will be in color, where cooler objects are represented by blues and purples, and the warmer objects by orange and yellows. But sometimes they are represented in grayscale, where white represents hot and black represents cold. Thermography is widely used by security and emergency services. For example, during the swine flu pandemic, airport staff used thermographic cameras to detect possible carrier. Okay, next is the cause of global warming. Combustion of vehicle fuels. Compared to N2 and O2, there is a very little carbon dioxide or CO2 in the atmosphere. This may be surprising to you because you may have heard the increases in CO2 in the atmosphere cause global warming. The amount of CO2 that we have in our atmosphere is just enough to trap heat from the sun to make Earth warm and comfortable. The planet will be too warm with more CO2 and too cold with less CO2. When we use fossil fuels, we add more CO2 to the atmosphere. The amount of CO2 produced by a single car is less than that produced by a large factory or power plant. However, many of us use cars every day and carbon dioxide emissions add up. The word emissions refer to the airborne gases and particles that comes out of the car's tailpipe when it runs. The combined CO2 emission and other pollution from cars on a day-to-day basis have caused many of our large cities to be noticeably hazy and smoky. During combustion of fuel in a car, the high temperature and high pressure in the engine causes nitrogen in the air, which is typically unreactive to convert to nitrogen oxides. Nitrogen oxides are reactant in the formation of ozone, the irritant to eyes and lungs. Nitrogen oxides also mix with water in the atmosphere, forming nitric acid, a component of acid rain. Acid rain originates from burning in one area, while its major impacts are often felt in faraway ecosystems. Pollutants from urban and industrial areas can travel great distances, affecting lakes and forests hundreds of miles away. Next one is the impact of global warming. There are a lot of the impact of global warming, but we will talk about the changing in living things. Global warming can have a tremendous impact on different ecosystems in the world. All living things from the simplest bacteria to the polar bears have certain adaptations that allow them to live in certain environment. When conditions in this environment change, they can either adapt to the new conditions, move somewhere else where the conditions are right, or else die. Unfortunately, not all living things will be negatively impacted by global warming. As temperature increases, many of the organisms that transmit infectious disease will get a big boost. As a result, the disease they carry will also spread. Take malaria, for instance. This disease is generally found in tropical regions and is carried by a particular type of mosquito that likes warm temperatures. As temperatures increase, so will the range of these mosquitoes. Consequently, the population of people will be at risk of infection. Okay, now we are going to the last part about the sustainable house design. Nowadays, households and other living areas in which people live or reside most of the time contribute CO2 emission and greenhouse effect as much as global warming, which threatens to all humans and their health, as well as natural resources which balance is disturbed a long time ago. Sustainable house or greenhouse or eco house is one of possible solutions, which with one part can contribute in solving of this global warming sustainable. We try to minimize the negative environmental impact of building by enhancing efficiency and moderation in the use of materials, energy, and development space. Most simply, the idea of sustainability or ecological design is to ensure that our actions and decisions today do not inhibit the opportunities of future generations. For a detailed explanation regarding a sustainable house, maybe you want to know what materials are suitable for use, the right location, and the benefit of a sustainable house, you can watch the full video here. And it is the reference that I used. Thank you for watching this video. Keep the ocean blue, the planet green, and the animals safe. See ya!